Hello, I'm teacher Ivan from Wunna Educational Services. I welcome you to our last lesson concerning solution or solving simultaneous equations. In our previous lessons, we saw elimination method and substitution method. Please, if at all you missed that, I request you to go to our playlist, go to O-Level Mathematics. You'll find those lessons, watch, so that we enjoy and move together. Otherwise, in matrix method, before we use the matrix method, we must know the adjacent or adjoint, and then matrix multiplication and the inverse techniques. That is from the topic of matrices. So it is always advisable that before you think of using matrix method, you must be well conversant with the topic of matrices. Majorly, how we get the adjunct matrix or adjoint matrix, then matrix multiplication, and then the inverse of a matrix. So let's go to our examples in this. The question says, solve the following simultaneous equations using matrix method. And this is what we shall be required of. However, before I begin, matrix method also has two cases. We have a case where we use the inverse technique and a case where we use the adjoint or adjunct matrix and then multiply. So in this particular lesson, we shall be looking at a technique where we use the adjoint matrix and multiply on both sides. Otherwise, let's try out number 1 or part A, which says 3x minus 5y equals to 2, and then 4x plus y equals to 5. So this is what we are to solve, and that means that by the end of our solution, we must have the values of x and y. So for matrix method, these are the steps. Step 1, we shall ensure that in both equations, one unknown comes first. We have x coming first and x coming first. That's okay. But in a case where we have maybe y coming first, let's say y plus 4x, then we first rearrange, so that the unknown coming first in the first equation should be the same unknown that is coming first in the other equation. After noting that and ensuring that, we now extract the coefficients. That is 3, -5, 4, and 1. Those are the coefficients of our unknowns. Then multiply by x. The one that is coming first goes up. The one that comes next comes down. This equals to 2, 5. And now that has been our first step. The other step is to get the adjoint matrix. Of 3, 4, -5, 1. The adjoint of this is how we get the adjoint. This is what we call the major diagonal. And in the major diagonal, the elements of the matrix simply interchange positions. The one goes up, the 3 comes down. That is 1 and 3. Then this is what we call the minor diagonal. And in the minor diagonal, they don't change positions, but change signs. The 4 is positive, therefore it becomes negative. The 5 is negative, therefore it becomes positive. So this is what we call the adjoint matrix. After getting the adjoint matrix, it's multiplied on both sides, but it must come first. This is what we mean. We are multiplying it here and there, but it should come first. So we bring it first, that is 1, negative 4, 5, 3. Times we bring this, that is 3, negative 5, 4, 1, and then xy. So it has come first on our left hand side, therefore it should also come first on our right hand side. So that is 1, negative 4, 5, 3, 2, 5, and now after that the required knowledge here is matrix multiplication. We multiply matrices by row and column. So that is 5 times 3 is 3 plus, sorry, this is 1 times 3 is 3, then 5 times 4 is 20. We also come to this, 1 times negative 5 is negative 5, and then 5 times 1 is positive 5. We go down, still multiplies the same, that is negative 4 times 3 gives us negative 12, plus 3 times 4 gives us 12. We come this side, that's negative 4 times negative 5 gives us a positive 20, plus 3 times 1 is a 3. Then xy equals to, the same applies here, this multiplies that, where 1 multiplies 2 to give us a 2, plus 5 multiplies a 5 to give us a 25. Sorry, this is 25. Then down, negative 4 multiplies a 2 to give us negative 8, plus 3 and a 5 gives us a 15. After that, we simplify now. This is 23. This is 0. This is 0. This is 23 multiplying by xy and giving us, this is 27, and this will be a 7. So once we are at that step, the other step is now still multiplication. Multiply this and that, so that is 23 by x, which is 23x, plus 0 by y is 0, then even down, 0 by x is 0, plus 23 by y is 23y. This equals to 27, 7. Therefore, we add and these are what we call equal matrices. So that is 23x and 23y are equal to 27 and 7. And now these are equal matrices whereby 23x equals to 27, therefore giving us x as 27 over 23. Similarly, 23y equals to 7, and therefore that gives us y as 7 over 23. You can always prove your answer by substituting in one of the equations. So let us do that and see. We have 4x plus y equaling to 5. Let us substitute and see. This is 4 into 27 over 23 plus that will be y, which is 7 over 23. Let's see if it gives us 5. So 27 by 4 gives us 108 over 23 plus 7 over 23. So since denominators are the same, we add the numerators. That is 108 plus 7 gives us 115. We divide by 23. That gives us a 5. Meaning our answers are very correct. So that is solving simultaneous equations by matrix method. And I'm leaving you with the part B and C for you to try out. Otherwise, that marks the end of solving simultaneous equations. We have seen 3 methods. That was elimination, substitution, and now matrices. We've left out graphical method. Maybe that will be for next time. Otherwise, I wish you the best. Please don't forget to subscribe, hit the bell, comment, and share so that we all enjoy the learning. Otherwise, bye-bye.